Hello students and welcome to classroom teaching. Students, today we are going to discuss today we are going to start a new chapter, that is effects of electric current. In this chapter we are going to discuss about 2-3 points only. We are going to see heating effect of electric current, then we are going to say the magnetic effect of electric current and actually their applications. Actually from last 2-3 years, that means from 8th standard, we know we are aware of this article, that is current electricity. So let us discuss about what we know or what we learned in earlier standards. How do we decide that any object, whether it is electrical conductor or insulator? Answer is simple. If the current flows through the wire or if the current flows through that object, then definitely that is a electrical conductor. And if the current doesn't flow through it, then definitely it is an insulator. So how the current it flows? We learned in 8th standard about static electricity. And when these charges, static electricity means the electrical charges, they are stationary. Whenever we rub something, then electrons, negatively charged electrons, they transfer to the other object and they are becoming positive and they are gaining positive and negative charges there. So if the charges sets in motion, in 9th standard we say, then it is called as current electricity. And suppose this is nothing but electrical conductor. So if I pull it, if I keep it in my hand in such a way, then can I get shock? No, because for the flow of electricity we require potential difference between the two terminals, between the two ends of the wire. There must be potential difference. So if the potential difference is created across two terminals, then electricity can flow from higher terminal to lower terminal. That we learn. That means the actual flow of electricity, it is nothing but the flow of electrons, that is negatively charged particles. But we know the conventional direction of the electricity, it is always from positive to negative. So let us discuss the energy flow in a circuit. So let us draw the simple circuit diagram. So in this circuit, the current it flows from A to B. That means definitely the current flows because the A terminal it is at higher potential and B terminal is at lower potential. Because A is connected to positive terminal, B is connected to negative terminal, and therefore definitely the current it flows from A to B. So this is the direction of electric current in this circuit. Suppose, what is the meaning of current flowing? The charges they are flowing. Suppose Q are the charges flowing from A to B. If we start the key, if we start the current, the potential difference between A and B, these two terminals, it is VAB. So how much work is done? We learned in last standard that potential difference V is equal to work done divided by Q. So how much work is done here? Work done, it must be equal to Q into VAB. This much amount of work is done in this resistance whenever Q charges they are flowing from A to B. So for this work to done, the energy is required. So from where it gets the energy? What is the source of energy here? Yes, definitely. Here, this battery or this cell, it is nothing but the source of energy in this case. It provides that energy through the charges Q to the resistance. This is nothing but resistance R. So the energy is provided to this resistance, and here the work is done Q into VAB. So suppose this work is done for time T, then this much amount of energy, how much? Q into VAB, this much amount of energy it is provided to this resistance AB for time T there. So because we know work done, it must be equal to energy provided by this battery, because this work is done because of the energy provided by this cell or this battery. So what should be the electrical power here? Look, suppose P is electrical power, then electrical power, it is nothing but given by energy per unit time. That means energy divided by time. So it is equal to, energy is nothing but work done. So it is nothing but VAB into Q divided by time. Suppose it is T. Energy divided by time. But what is Q upon T? We know Q upon T, it is nothing but electric current. Because we know what is electric current? Amount of charges flowing through the circuit per unit time. So Q is the charges and T is time. So Q upon T must be I. So this electric power, it is given by V into I. Here V is nothing but VAB, between AB. VAB, it is nothing but potential difference across A, B terminals. So V into I. So this, what happened to this electric power? We know the energy. So in this case, if we try to calculate the energy, what is energy? Energy, it is nothing but P into T. From this equation we can get energy is equal to P into T. So it is nothing but energy, it is nothing but P into T from this equation. So now tell me what happened to this energy here. Because we learned the law of conservation of energy. Energy cannot be created nor be destroyed. So what happened to this energy? Whenever Q charges they are flowing through it for time T, then the energy, it is converted. Here the electric power which is used here, that energy is converted into heat energy here, and therefore this resistance temperature, the temperature rises. So it becomes very hot. That means the heat is produced. From where the heat comes? The energy which is used here, it is converted into heat energy. So this energy, it is nothing but heat energy, H, is equal to how much? P into T. What is P? V into I. So V AB into I into T. So this is nothing but the heat generated whenever the current I flows through the circuit, where the potential difference is V for time T, then the heat generated in the resistance it is nothing but VIT. Let us consider, instead of this resistance, if we connect any motor here, then what happened to that energy? That energy is definitely transferred into mechanical energy. If I connect any CFL here, then what happened? That electrical energy definitely converts into light energy. So depending upon the gadget we are using here, the energy it converts into another form. Electrical energy is converted into another form of energy. So here in this case, the energy is converted into heat energy, which is given by V into I into T. But we know, by using Ohm's law, we can write V is equal to IT. V is equal to IR. V is equal to IR. So what is I? I is equal to V upon R. So put this value of I in this equation. What we get? Heat is equal to heat generated. It is equal to, instead of I, we are writing V upon R. So V into V upon R into T. So we get V square upon R into T. That means V square T upon R. So this is also the same equation like this. If we place V is equal to IR, we get heat energy is equal to, in this equation, V is equal to IR. Instead of V, we are writing IR. So I into R into I into T. So it is nothing but I square R T. So this is again third equation. By using any of the equation like H is equal to VIT or H is equal to V square T upon R or H is equal to I square RT, we can calculate the heat generated in the resistance. And this is called as heating effect of electric current. That is nothing but Joules law. It is nothing but Joules law of heating. There are so many applications of this Joules law or this heating effect of electric current in our daily life. Let us discuss few of them. So before saying the applications of this heating effect of electric current, we got these three equations which are nothing but Joules law of heating, the equations of Joules law of heating. Any of the equation we can use for that. And let us find out the unit of electric power first. So electric power, it is given by P is equal to V into I, that we see earlier, V into I. V, it is measured in volt into ampere. So volt into ampere, but volt it is given by 1 volt, it is nothing but 1 joule per coulomb, and it is 1 coulomb per second. So write down the values. 1 joule per 1 coulomb into ampere means 1 coulomb per 1 second. So this get cancelled out. So power, unit of power is joule per second, and it is nothing but watt. One watt, it is equal to 1 joule per 1 second. So this is nothing but the unit of electric power. Students, the effect of electric current, heating effect of electric current, we can see it in electric cooker or electric heater. the coil which is used there, that coil, it has high resistivity, and due to its high resistivity, that coil gets heated, and here the heat which is given out or heat which is generated, that we can calculate by this formula. So that is nothing but heating effect of electric current is applicable there. In water heater or room heater, anywhere where the heat is generated. Secondly, we can use this heating effect of electric current in electric bulb also. The filament of the bulb, it is made up of tungsten, which gets heated whenever electric current flows through it. And this, after heating it, emits light and also heat is given out. Whenever it is heated at very high temperature, it emits light, it gives off light. The temperature, it is nothing but 3400 degrees centigrade. And therefore, the tungsten is used there because the melting point of tungsten is higher than that. And for electric heater or geyser, or we can say electric cooker, the coil which is used, that coil, it is made up of a special type of alloy, that is nothing but nichrome, which is a good conductor, but it has very high resistivity, and therefore large amount of heat is generated. Then several times we can say, we learned about fuse also, that also works on heating effect of electric current. Whenever the excess amount of heat is generated, whenever excess amount of current flows through the circuit, then large amount of heat is generated, and the melting point of that fuse wire, it is very less, and therefore it melts and it breaks the circuit, and it protects the equipments or the gadgets which we are using at the home. Many times we hear about the mishap due to the short circuiting. What is short circuiting actually? Short circuiting means if the electric current, it gets the shorter path to flow. What is the meaning of shorter path? Shorter path means if it gets the very close path, that means if neutral wire, we know there are three types of wire: live wire, neutral wire and earth wire. If live wire and neutral wire, the insulation of those wires, if they are removed, and if there is a direct contact between live wire and neutral wire, then electric current starts flowing through that point. So very large amount of current flows through the circuit, and due to that very large amount of heat is given out, I square RT. If electric current increases, heat also increases, very large amount of heat is given out. And if some inflammable substances like plastic, wood or curtains, they are present there, then definitely they catches fire, and due to that the fire may be there in buildings, that we know. There are so many such accidents. Excess amount of heat is generated whenever large amount of current flows through the circuit. We know in summer, in the evening, we use ACs, the lightings we are using, and due to that overloading may occur. Overloading means the same. If the very large amount of current is used in the circuit, then due to that the large amount of current flows through the circuit, or large amount of current required from the transformer, then also very large amount of heat is generated and the transformer, it burns. That means the fuse which is used there, it burns. So all these are nothing but the heating effect of electric current. So we will stop here for this article. In next article we will say about the magnetic effect of electric current. So thank you very much.